All right, so a little review before you test. All right, again, when you look at discrete versus continuous, discrete you count with whole numbers, counting the number of books on your desk, the number of drinks that you bought at the store. Discrete are countable in whole numbers. Continuous is like your number line. It has all the numbers in between. If you can say, can I do a half of this, then you have continuous. So in other words, if I want to look at the number of pumps at my gas station, can I have a half a pump?
No.
No, I'm discrete. The weight of a truck, can I have a half a pound? Like 2 tons and a half. I'd have continuous. So discrete is countable by whole numbers. Continuous, you can have a fraction, decimals. Just ask yourself if you can get half. Now, 2 things, and this always gets confusing. The difference between a probability distribution and a binomial probability distribution. A probability distribution says only 2 things have to happen. Your probabilities have to be between 0 and 1, and your sum of all the probabilities have to add up to 1. That is also present in your binomial probabilities. Your binomial just goes a little step further, which we'll get to in a second. So just to have a probability distribution, make a graph, do whatever you like with this, you have 2 situations. So all we had to do was check. Do these fall between 0 and 1? Each one of these? Yep. Do they add up to 1? Nope. They added up to 1.1. Now, when we calculate our own probabilities, we round. So sometimes it's 1.001. If they give you a table, it has to add up to 1. Right? Because they're not going to round, but it's going to add up to 1. Ours is a little tiny bit off because of our rounding, but close enough. This guy, check the probabilities first. Are all of these between 0 and 1? Yep. And then none of them can be negative. Do they add up to 1? Yep. Then this is a probability distribution. Stop me if you have any questions. Okay. Number 11. This was a good one. You probably might see something very similar to this tomorrow, the lecture. You were asked, this is what they asked in number 11. They said the number of pages in a section from a sample of statistics test. So, they said, how many sections had 2 pages? 3 of them. How many sections had 3 pages? 12 of them. How many sections had 4 pages? 72 of them. So, or 4 sections, 72 pages, whatever. So, you're looking at an X and a frequency. We did these many times, L1, L2. But if we're going to calculate your probability, you have to be able to add all this frequency up, and probability is just your part over whole. It's like your relative frequency. It works just like relative frequency. 3 over 650. Not the X. The X stays the same. The X doesn't change. The X, leave the X alone. So you'll be this, X 0.005. So that'll give you another L1, L2 in case you use that. So we just take these and we place them over part over whole. Now, if you put this in L1 and this has L2, this will still give you the same mean, the same variance, the same standard deviation, except it just will not give you a sample standard deviation. Because a sample standard deviation, if you remember back to your standard deviations, and here was your formula. This was for your variance, then we took the square root of it. A sample one says n minus 1. So if you subtract 1 minus 1, you get a 0, and you can't divide by 0. That's why you don't get a sample standard deviation. But the population one is fine. It is exactly the same. All of these have to add up to 1. And you might be a little bit, tiny bit off in your rounding, but we can assume that they add up to 1 if you do them correctly. Now, when you put this on your graph, and I know from the other graphs, there's always a little problem labeling. Everything has to be evenly spaced. I cut my graph because I started at 2. You could 0 and 1 didn't exist, so they had nothing with 0 pages or 1. So now, I started my graph here. When you do your y-axis, think of money. You're basically, God bless you, you're basically 2 digits here. It's like money. The highest, I'm going from 0, 0, all the way up to, my highest is about 26 cents. So make sure you cover all the way up. Well, maybe the top one's a little bit higher, right? No. Make sure you cover at least up to 26, 30 cents. Make sure they're evenly spaced. Do not use these values to put on your y-axis. Make sure you give it a title. Make sure you label your axes. Your graph is something you present at the end of all your findings. That has to tell your whole story. So if I looked at this, is this like close to a normal curve? Would you say this is fairly representative of a normal curve?
Yeah.
Yeah, pretty nice representative of a normal curve. Also, because there's really no work, you're just putting it in your calculator, make sure on your test that you show me this statement. I want to see where this comes from. Maybe it came from your neighbor. I want to see where it came from. It comes from your neighbor, give me your name on it, or his name. But put this out there so I know where this came from. Zoom in. Whoops. A little bit too big of a zoom, huh?
Too much zoom.
No, that won't matter.
Oh, bless you.
Can you see that better or no? Or was it the same exact? I don't get this. My Zoom's not working. Either going. There's no in between for this for some reason.
Oh, God. Oh, no. Oh, no. It's in 200%. It's in 200%. Uh-oh.
This might help. I don't know. Let's see if my handwriting shows that better. Better? Better?
Yeah.
Okay. Let me clear my ink. Okay. Guys, come on. Right, so now, make sure that your graph is labeled correctly. Otherwise, you're going to have missing information on your graph. Okay? And show me your work.
Wait, can you explain this to me,
Explain this to you
though?
on your calculator.
Variance is the square root of standard deviation?
Variance is your square of standard deviation.
So the standard deviation squares.
Your calculator, guys, your calculator gives you this. This is your mean. This is your standard deviation. To find your variance, you have to square your standard deviation. You could go to VAERS, number 5 statistics, come down to this guy, and then hit the square button. That's the easiest way to do it. Most of the time, not most of the time, but a lot of the time, the variance is a nice number. When you take a square root, it's irrational. So the calculator knows that when it goes to re-square it. Okay? We're good so far? Guys, come on. Hold your conversations down. I just want to go a little bit less. Guys, this is your review, not mine. I don't care if we don't get through it because you're still having the test. Okay, number 15. Number 15 says, find me the expected value. Expected value is the same as your mean. When we were doing this unit, we also did this. This times this. and we got this piece right here. Then we took the sum of this whole thing. This is our mean. But we then said, okay, we know how to calculate with expected value, but we could very easily put this in my L1, L2, and find my mean. So L1, L2, and you get your mean. Your mean is your expected value. What do you expect to happen? When you get an expected value, over the course of time, you expect it to be close to this number. Like we did the other day, and we said something came out with a decimal in it. We said, how could we have 0.2 people? But over the course of time.
Is there an unexpected value?
If you're unexpected, that would be your pleasant surprise when you're gambling. That would be your pleasant surprise, but there is no unexpected.
Just making sure.
But that would be your pleasant surprise. So you can consider your expected value to be your mean. Again, that's a field of study in itself. For our basic purposes, it's just our mean. All right, number 20. Now, number 20, you can do this a number of ways. I'm still getting a little bit of trouble here. Okay, you can do this one a number of ways for number 20. All they cared about was exactly 4, fewer than 4, at least 4. So if you catch what they're asking, you can look for the one with the 4. And then you can do the less, you can do the cumulative, you can do the 1 minus that. When we went through doing this, I said, it's just easier, make the table. And then you don't have to worry about, did I cumulative, did I count the 4, did I not count the 4? Go 1 through 12 on your table. 1 through 12. You can either do it this way with Bernoulli's, or you can do it in your calculator under second bears and go down to the one that says binomial PDF. Once you get your table, you can pull out your exactly 4. Your at least 4 says I want 4 or more. So I add up these pieces. Now watch these significant digits. If anybody gives me an E on their table, I'm not counting it. Your calculator will say, for instance, it will say 6.0 e to the negative 4. Don't give me that on your table. This says 10 to the negative 4. Move your decimal 4 places. 1, 2, 3, 4. Fill it with zeros. If you're moving it 4 places, you're adding 1 less, 3 zeros. This is what I want to see on your table. Don't give me the E in there, because what happens is you end up adding the 6, and your probabilities are well over 1. So normally we say 3 decimals, but you have to go out to a significant digit. Yes.
Like for me, I got 0.206. Is that like, are you
Oh no,
that wrong?
No. That's
around
fine.
it?
Yeah, that's fine. And sometimes when you use your calculator with the cumulative, it is a little bit off because your calculator doesn't do any rounding at all until at the very end. So I totally understand those. I understand those. Okay, again, what happens here was, if it's more than 4 is not counting 4. It's 5 or more. So you could actually do your cumulative up to 4 and then subtract it from 1. You could do that if you like. But since you have your table, I wouldn't even mess with it. I would just say more than 4, add these up, and I'm good to go. Your cumulative works very nicely, but your cumulative goes from 0 and stops at the one that you want to include. If you don't want the 4, then you got to stop at the 3. Okay? You got to go up. If you want the 4, then you got to stop at the 4. If you don't, then you stop at the 3. So it's a little trickier on the cumulative. So I would just make the table and go with the table. Can everybody make this table? Yes.
I know this could be a good question. I just had a brain fart. What's at least again? At least 4.
At least think of money in your pocket. You have at least $2. We go to the store. I say, Darian, I might run out of money. You say, oh, that's fine. I have at least $2 on me. You have 2 or more. That's the least you have.
So then,
So you can-
4 and more. So B and C is the same thing.
No.
Oh.
B
More than
says
4.
at least 4. 4 or more.
Okay.
This one says more than 4. Right, so 5 is more than 4. Yeah. The only one you don't want is this. So technically you can take that answer and just subtract that guy out of it.
Yes.
Because it's the only one that was overlapping you. You can do that as well.
We have to show the whole graph when it says.
You have to show me the table if I ask for the table. On a test, the most you go up to is 8. There's one table with 5 and there's one table with 8. That's really not that bad. Once you do this binomial, even if you do Bernoulli's, it's just a matter of second enter, second enter. Okay. Again, this one, 21, said 43%, so your P is 0.43. You received, then blah, 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 blah. You didn't have 21? Uh-oh, it looks like I left it out. 23. Okay? 23. 63% of adults, and we're sampling 5 adults. So N is 5, P is 0.63. Be careful of the 0. You could have none but answer. No positive answers on this. So this is your binomial. You have 2 choices, fixed amount of times, your probability doesn't change, and your X value goes from 0 to 5. This is what your binomial probability distribution does. Your probability distribution said 2 things, between 0 and 1 and the sum of 1. The binomial adds 4 more things. 2 choices, a success and a failure, fixed probability, n number of times, n number of trials, and your X value goes from your 0 to whatever it is going to. That's your binomial part of this. Binomial meaning 2. All right, so everybody can do this part? All right, so from there, we go down here, and we can make your graph with this. Again, you're making your graph. This is your X. This is your Y values. There's a slight little skew to this. Do you see it? Look what your probability is. Your probability is 0.63. It's skewed to the left. Good. A slight little tail. Because remember when we checked your probabilities? This one, your probability is 0.63. If it's 0.5, it's a nice normal curve. If it's greater than 0.5, then it's skewed to the left. Because if you think about it, more people will respond favorably if the probability is higher, right? If the probability is very high, that you'll get an 80 or above on my test, I expect more of you to get an 80 and above than less of you, right? If my probability is less, say my probability is 30%, I expect less of you to get an 80 or above, right? If your probability is less than 0.5, then you're going to be skewed to the right. Those numbers are going to be smaller. Okay, we talked about your skewing on this. Okay, and the last part, your mean, your variance, and your standard deviation. There's not enough here to do an L1 and an L2. So therefore, we're going to use your mean, your variance, and your standard deviation. There, actually, you could use your L1 and L2, but for these guys, use this. Now, in this one, you're going to find your variance first, and then take the square root of that to get your standard deviation. Your rule of thumb with your decimal places, remember, go 1 more than your data. So since our data is discrete and has no decimal places, go 1 more.
But we can round
Oh,
it
there's
and
just
that,
falling.
like all the.
Yeah, yeah. Okay, so tomorrow, guys, test tomorrow.